Hello everybody and welcome to Work Against the Grain. My name is Jeff. Going to try to make this as fast as we can as it relates to the dovetails, doing dovetails on a CNC machine. As some of you may have watched my previous video on the Vectric dovetail gadget, it does a really good job of doing the dovetails, but you end up with these fillets because you're using a round bit, and so there's no real way to get rid of these gaps, which kind of defeats the whole purpose of the dovetails. Now you could use wood filler, I guess, but and they fit great, and it's a great gadget. And you know, if you're putting some drawers together or something that maybe you don't see but you want the strength, these would certainly work great. And so what I wanted to do was figure out a way to do dovetails on a CNC machine without having those fillets. And after a lot of research and a lot of time, energy, and effort, I have come to realize that the only way that we can do that is if we have a dovetail bit such as this that has a radius here, so that when you fit the pieces together, you don't have those fillets and those gaps. And so what I had to do first is that the company that makes the bit has a drawing. And so I had to trace the drawing to make a tool, and we'll talk about that as we move forward a little bit. But I wanted to make sure that I had this radius in here correct and that this was a 1/4 inch, because I know that the distance of the bit from one edge to the other is a 1/2 inch. And so through some measuring and through some trial and error, I was able to come up with a tool that I called the Vortex Dovetail bit, and here it is here. Now, the problem with the not the problem, but one of the issues that Vectric has, and most CNC programs have, is they can't show the undercut in the 3D video. And so really at the end of the day, all you really need to know is the overall diameter of the tool, and you need to know the cutting diameter of the tool, and you need to know how deep the tool can go before you start hitting the part of the tool up here. Because at the end of the day, all the CNC machine really cares about is the middle of the bit, the center of the bit, where it's going to travel. And so what I wanted to do was I just wanted 3 real simple dovetails cut into some plywood for demonstration purposes. And through a lot of trial and error and understanding how the bit flows, I knew that I needed some vectors for the Vortex Bit to travel on to cut the pin board. And then I knew I needed to create a tail board to cut out with a 1/4 inch end mill that accompanies the Vortex bit when you purchase it. And so there were some various things that we had to do. Number one, we had to make sure that when we cut the pin board, that the tails lined up perfectly with that. We had to understand how deep the Vortex bit was going to travel into the wood, because as you know, and as we talked about earlier, this bit we know is a 1/2 inch in diameter. And so you have to understand that when this bit is traveling along this vector, how deep it's going into the wood. Because you can see here, it's going to go, the center of the bit is going to follow this vector. And you had to translate that into the tail so that when you put the two together, you had proper registration. And so these vectors are relatively simple. I brought them in from the end. They came in and went out with space. It is a plunge bit, so you could batch out an entire plywood sheet of these where this bit would plunge into the vector, cut your dovetail, and then ultimately with a 1/4 inch end mill, you could come in and cut this out. When I said cut your dovetail, I meant your pin board. Then for the tail board, this is all done with the 1/4 inch end mill here that accompanies the Vortex bit. And let me get rid of these here. And so this 1/4 inch end mill, we had to do a couple of things. One thing that you want to do, obviously, is cut the whole thing out. So it's going to travel along these vectors here. And maybe if I turn the tool paths on, it'll make more sense. Cutting out of the tails was really easy. You just go outside the line and it cuts the tails. Now, keeping in mind that you're going to have a radius here, right, because it's a round bit, but that's what the radius on the dovetail bit is for. This radius right here, so that when you cut that tail out, it fits properly into the slot and you don't have any gaps. It's a really nice tight fit. And so then I also found that if I'll turn that one on, or excuse me, off, I also had to give a little bit of a relief in here in terms of depth for how deep the dovetail was going to go into the pocket. Now, this is the way that I did it. I could spend some additional time to understand how deep the dovetail bit is cutting in, and you may not need that relief, but when I show you the machining, it'll make some sense to you. And then we also wanted to take this bit, as you can see here, and cut just a little bit of a relief, and let me turn that one on. So this tool path here is going to bring this 1/4 inch end mill, and it's going to follow this tool path here, come in there and cut a little bit of a relief. See how that fits there? Come down here, come across there, back out, and then end right here. And that gives me a little bit of a relief here that, again, you'll see in the machining process. So once I understood how the Vortex bit was going to cut into the plywood, and once I understood how the 1/4 inch bit, or excuse me, the Vortex bit was going to cut the pin board, and the 1/4 inch bit was going to cut the tails out, then I could take it over to the machine, run a test program, and see how they fit. Now, on the first couple of passes, my, wrong drive, I didn't do really good. And so if you look at this picture here clearly, you can see the dovetail part, but I didn't get the pin board right. The depth of the pin, too big of a gap. And then if you look on this one, we got a little bit better fit where and this is for a offset dovetail here, where we seem to have a pretty decent fit between the dovetail bit and the 1/4 inch bit. On the inside, as we talked about that relief, is when the dovetail was flush, I brought the Vortex bit in too deep here. And you can't have this kind of mess when you're trying to make some nice looking dovetail drawers, right? And so as I went through this, I got to a point where I was able to get the offset dovetails so they fit really nice for your offset drawers. And then for the flush through dovetails, I was able to get a really nice fit as well. And I just used some walnut plywood to illustrate this. And so anyway, long story short, it is quite a learning curve to understand how the bit is traveling. It is quite a learning curve to be able to understand how to draw the vectors so that the bits will follow. You got no room for tolerance here, so it has to be exact. So I tell you what, let's do. Let's jump over to the CNC itself. Let's watch the bit in action, and then we can talk further about how we can improve on this process and some of the other things that we can do to make it better. So come on over to the CNC with me and we'll have a look. Okay, so this first video is me attempting to do offset half-blind dovetails. And so here the machine is cutting the offset first, and then it will come in and cut with the dovetail bit. And then the second video, you're going to see the tail board that I cut out of maple because I thought it would be a nice transition. But then it didn't work. And wait till you see the gaps. But I want to show the mistakes, talk about some of the frustrations, and then show you the final finished product. As we talked about in the Vectric software, it was a lot of trial and error, making sure that the depths were right and that the passes were correct and they followed the vectors properly. But here's the bit in action. And again, you could plunge, but I chose to come in and come out. Just makes a really, really clean cut. I'm using plywood because we're just kind of experimenting here. So there's the the pin board, I guess this is. So this is the three pins that the dovetails will slide into. And then let me fast forward a little bit here. This is just cutting out the pin board. But how fast is that, right? If it works and you can do it on the flat, you see the offset there. This again was offset half-blind dovetails. So let's fast forward and then we'll have a look at the tail board. Okay, so here we are cutting the tail board, and when I did it the first time, as I talked about, a lot of trial and error, but this was me wanting to put some hard maple into the plywood to show the contrast. You saw the pictures of that earlier in the Vectric video and how horrible the gaps were, but I wanted to show you where we made our mistake. So this is cutting the relief. One of the relief passes that I thought would be enough for the tails to go into the pins, but it didn't work, as you will see shortly. So this is the relief, then you'll see the tails cut out, and then I'll show you what that looked like. And horrible. So you can see there it's an offset or half blind offset half-blind dovetail. Gaps are horrible. Nothing worked. It was miserable and looked bad. And so then through, again, a bunch of trial and error, making sure the vectors were right, the depths were right, I went ahead and came off of the offset and just said, you know what, let me just try some half-blind dovetails, no offset, back to the drawing board. And so this next video that you're going to see is once all of the kinks got worked out, it's going to first cut the pin board using the dovetail bit, and then it's going to come in and cut the tails, and I'll talk to you about it after it's done. Okay, now as you go through this video and you're watching this, imagine you've got an entire sheet of plywood and you got to batch out a whole bunch of drawers. This is absolutely going to do it. Again, I'm just doing, one corner of little scrap pieces just to show the process. But once you get to this point where you've worked out all your kinks, and your depths are working properly and your cuts are going the right way, then you're set up. You've got everything squared away, and now you can batch out, 50 or 60 of these at a time if you have to, on a piece of 48 by 96 plywood. And so there it's making the relief cut on the pins, and then you'll see it do a little pocket just to pocket down on the pins a little bit so that we could push the tails all the way in and not have any gaps on the inside. So that's what you're going to see next, and then you'll see it cut out the entire tail board, and then we'll come back and show some pictures. And so this part's pretty simple. That's where the dovetail bit cut into the plywood. Makes a really nice clean cut. Got a really nice undercut area for the dovetail. And so that's our pin board. And then here's the tails. You can see there as I zoom in here, and I'm sorry about the brightness, but you've got the relief on the edges of the tails, and then you've got the pocket relief on the face, if you will, of the tail. And then you've got the full tail out front. And this gives us plenty of glue surface, plenty of strength, and worked out really good in the end. And then here they are put together, half blind dovetails. Again, I just did 3. You could make these as small as a 1/2 inch each, or you could make them, you know, as wide as you wanted, because you just need the entry point and the exit point. But like I said, once I had the setup to where it fit like this, I was able to batch out. I built some file cabinets, and I was able to batch out 16 drawers with 4 dovetails in each drawer. And it went like clockwork. It just was absolutely fantastic. So in the end, you got to have the bit that has the radius so that when you cut out your tails and it creates that radius in the corner, you have a radius on your pins to allow the dovetails to slide in. And then here are the offset half blinds. Again, I wanted to come back and do some of those as an example to get that right. And again, once you have your setup now, I've got it for half blinds and for offset half blind dovetails. Can batch them out really quick. Looks good. At the end of the day, does it look as good as, you know, the Mac Cremonas of the world that hand cut their dovetails? No. But with some contrasting woods, Padauk and maybe maple, would this look really good? Yeah, I think so. I mean, I practiced in plywood because it's cheaper just until we could get it done. But at the end of the day, I was really happy with how they turned. And so there you have it. Offset and regular half-blind dovetails with the Vortex bit on the flat CNC table. Again, I'm pretty pleased with them. Here's a link right here that if you'll click this link, it'll take you to Legacy CNC Woodworking, where they did a video on creating the vectors for a bit such as this. They go into a lot more detail than I did in the Vectric software. They use TurboCAD instead of Vectric to draw the vectors and then bring it into Vectric. But I just use Vectric to create the vectors. Had a lot of fun doing it. Hope you enjoyed it. I really appreciate you hanging in there with me. I've got some other stuff coming up here pretty quick. Got a little bit of time off, so hope to get some videos out to you. Thanks again for watching. This is Work Against the Grain. My name is Jeff.